It's April 2019 in Berlin, Germany. Construction crews are putting the finishing touches on what was supposed to be one of Europe's most advanced airports. The project has already taken 13 years and cost €3 billion. But as engineers run their final tests, something goes catastrophically wrong. Warning lights flash across control panels. Emergency alarms blare through empty terminals. Within hours, the opening ceremony is cancelled indefinitely. This is the story of how a single engineering oversight brought down one of the most ambitious infrastructure projects in modern history. Picture this. You're standing in the middle of what should be a bustling international hub. Instead, you're surrounded by empty check-in counters, silent baggage carousels, and gates that have never seen a single passenger. The silence is deafening. This isn't some abandoned relic from decades past. This is Berlin Brandenburg Airport, and it's brand new. When construction began in 2006, Berlin Brandenburg was meant to be Germany's crown jewel of aviation infrastructure. The project promised to replace the city's aging airports with a state-of-the-art facility that could handle 45 million passengers annually. Politicians posed for photographs at groundbreaking ceremonies. Engineers presented ambitious blueprints featuring cutting-edge technology. The media hailed it as a symbol of German precision and efficiency. But somewhere between those glossy presentations and opening day, something went terribly wrong. The project became a nightmare that would consume careers, drain public coffers, and embarrass an entire nation. What started as a routine infrastructure upgrade transformed into one of the most spectacular engineering failures of the 21st century. The warning signs appeared early, but nobody was listening. In 2008, just 2 years into construction, the first delays were announced. Project managers assured the public these were minor setbacks, standard construction challenges, they claimed. Nothing to worry about. The opening date was pushed back by just a few months. Those few months became years. Each delay brought new excuses, new explanations, and new promises that the problems had been solved. But behind closed doors, engineers were discovering that their beautiful designs had a fatal flaw built right into the foundation of the entire project. The heart of any modern airport isn't the runways or the terminals. It's the invisible network of systems that keep passengers safe, planes on schedule, and operations running smoothly. Fire safety systems, baggage handling networks, flight information displays, security checkpoints. These systems must work together seamlessly, like instruments in an orchestra. When one fails, the entire symphony falls apart. Berlin Brandenburg's engineers thought they had created the most sophisticated airport control system ever built. They integrated everything into a single, centralized network that could manage every aspect of airport operations from one location. It was supposed to be revolutionary. Instead, it became their downfall. The system was incredibly complex, with over 50,000 individual components that needed to communicate with each other constantly. Smoke detectors had to talk to ventilation systems. Baggage scanners needed to coordinate with conveyor belts. Gate displays required real-time updates from flight scheduling computers. Every single piece had to work perfectly, or nothing would work at all. During initial testing, engineers noticed strange glitches. Sometimes the fire safety system would trigger false alarms. Other times, baggage handling would mysteriously shut down for no apparent reason. Flight information displays would show incorrect gate assignments. These seemed like software bugs that could be patched with updates and fine-tuning. But as testing continued, the problems multiplied. The false alarms became more frequent. System shutdowns lasted longer. Gate assignments became completely unreliable. What had looked like minor software issues were actually symptoms of a much deeper problem. The entire integrated system was fundamentally flawed. The engineers had created a technological house of cards. Every component depended on every other component functioning perfectly. When one piece failed, it created a cascade of failures throughout the entire network. The more complex they made the system, the more ways it could break down. And when it broke down, It broke down completely. Airport officials tried desperately to find solutions. They hired new consultants, brought in software experts from around the world, and spent millions on system redesigns. Each fix seemed to create new problems. Each update introduced new bugs. The opening date was pushed back again and again as engineers struggled to make their creation actually work. Meanwhile, the costs kept climbing. What began as a €3 billion project ballooned to over €7 billion. Construction crews worked around the clock, making modifications and adjustments based on the latest engineering recommendations, but they were essentially trying to fix a fundamentally broken design while the building was already complete. The breaking point came during a routine smoke detection test in Terminal 1. Engineers activated the fire safety system to verify emergency protocols were functioning correctly. Within seconds, chaos erupted throughout the building. Ventilation fans began spinning at maximum speed in areas where no smoke existed. Emergency lighting systems flickered on and off randomly. Baggage conveyor belts started and stopped erratically. Gate information screens displayed nonsensical flight data. What should have been a simple 30-minute test turned into a 12-hour nightmare. Engineers watched helplessly as their integrated system spiraled completely out of control. Every attempt to shut down one malfunctioning component triggered failures in 3 others. They couldn't isolate problems because everything was connected to everything else. The fire safety system, ironically designed to save lives, had become the airport's greatest threat. If a real emergency occurred, passengers would face a maze of contradictory signals, malfunctioning exits, and unreliable evacuation routes. No regulatory authority would ever approve operations under these conditions. By 2012, 6 years after construction began, Berlin Brandenburg had become a national embarrassment. German media dubbed it Ghost Airport because of its eerie emptiness. International news outlets used it as an example of German engineering gone wrong. Politicians who had once celebrated the project now distanced themselves from it entirely. The technical problems went far beyond software glitches. The integrated system created physical challenges that nobody had anticipated. Smoke detectors were so sensitive that construction dust triggered false alarms dozens of times per day. The ventilation system was so powerful that it created pressure differentials, making doors impossible to open in some areas. Baggage handling equipment vibrated so intensely that it damaged floor tiles and ceiling panels. Airport authorities brought in a parade of experts, each promising they could solve the problems. Software engineers from Silicon Valley, systems integration specialists from Japan, aviation consultants from around the world. They analyzed code, redesigned networks, and proposed countless modifications. Some improvements worked temporarily, only to create new issues weeks later. The root cause became increasingly clear to everyone involved, though few wanted to admit it publicly. The entire concept of total system integration was flawed from the beginning. Modern airports don't actually need every component connected to every other component. In fact, that level of connectivity creates more problems than it solves. Traditional airport designs use isolated systems that operate independently. Fire safety works on its own network. Baggage handling has its own controls. Flight information runs separately. If one system fails, the others continue operating normally. It's less elegant from an engineering perspective, but infinitely more reliable in practice. By October 2020, 14 years after construction began, Berlin Brandenburg Airport finally opened its doors to passengers. The integrated system that had caused so much trouble was largely abandoned, replaced by simpler, more reliable technology. The airport that was supposed to showcase German innovation instead became a cautionary tale about the dangers of overengineering. Sometimes the most sophisticated solution isn't the smartest one.